this new video in which I'm going to show you how to perform the principal component analysis in RStudio. As you know, the principal component analysis is a method of dimension reduction that is used in order to summarize information contained in database containing many variables in some individual. So in this tutorial, we have a data set containing information related to the household. And we have for the purpose of this video, we have 12 household with information on the revenue, consumption, expenditure. We have number of household member. We have the professional experience in here. We have as well level of studies. So in this video, we're going to demonstrate how to you can use the principal component analysis in order to summarize individual characteristics according to the relation of some variables. So I've already imported my data set. First of all, to define the variable in which that we are going to use in order to run our principal component analysis, and for this purpose I will generate a matrix called data by concatenating variable that I use in my data set, like revenue. I will concatenate revenue, consumption, expenditure, number of household member, professional experience in year, and level of study. So 1, 2, 3 for primary, secondary, and higher education. First of all, use the concatenation. Concatenate our different variable as I said using command cbind base, meaning that we're going to use the data set base $sign followed by the name of our first variable, which is the revenue. Our second variable is consumption expenditure. We use the base dollar followed by the name of the variable, and so on for all other variables. I will use this command in order to concatenate my different variables. So it's the first time you are watching one of my videos, do not hesitate to subscribe to the YouTube channel as well as hitting the notification bell in order not to lose the next video. So in principal component analysis, one package is required. Package required, this is FactoMineR. So FactoMineR is a package that you need to install in your RStudio if you want to perform the principal component analysis. And here is a command to install install.packages factomin into quotation mark. As you have installed your package FactoMineR, you just use charge your library in RStudio. So package FactoMineR is already charged in my RStudio. The first step is to perform properly the principal component analysis, and I will give it by the name result.PCA for a result of principal component analysis, that I will assign the value of the function that is used to perform the principal component analysis. PCA bracket, the first parameter is the data set that I use, that is data, which is the concatenation of my different variable of my data set, and we have graph equal to false. So I will select the principal component analysis implementation and then click on run, and the principal component analysis method have been implemented in my RStudio. So the next steps are just to perform the eigenvalues computing. We have to visualize variable with the same variable. So first of all, let us compute the eigenvalue of our principal component analysis by using the command res.pca dollar, because my principal component analysis results is called res.pca. So I follow the name of our principal component analysis by the dollar symbol hey for eigenvalue. So then select our command, then click on run, and our eigenvalue has been computed, and you can see that the first component eigenvalue is 3.4848, representing 70 as almost 70% of the cumulative variance. The second component principal eigenvalue is 1.05, representing more than 20% of cumulative percentage of variance. Here is our eigenvalue percentage. We can as well visualize our eigenvalue by using the bar plot, using the command bar plot. Here is the command, then we just select it and then click on run, and we see in our right hand side the variance explained by PCA. Here is the first component that represents almost 70% of variance. Second axis represent 20%, and the interpretation that we can have, we can also as well add a line to our eigenvalue visualization. So we can see that there is a line that's used to describe the decline of our principal axis, principal component, and the interpretation for our eigenvalue are that the third component have a eigenvalue that is less than average eigenvalue, meaning that you can just use the first two components, because the third component represent less than an average variance of our sample. So we just use the first two components in order to analyze our individual. So as we have just plot a eigenvalue graph, we can just represent the individual graph by plotting individual graph using the plot for our principal component analysis result using choice is individual for IE IND for individual. Autolab is yes. Then we click on run, and we can see that our individual will just be represented in the left hand side of our RStudio interface. So we have the representation of our individual that are just in the first plan. So we have a group of according to our diagram, we can set two principal group of individual. The first group is the one on the left hand side, and we can also have a second group of individual here according to the characteristics. So we can as well plot the correlation circle representing the correlation between variable using plot result principal component analysis. Schwa is equal to R for variable plot. So then we click on run, and the correlation circle will here in the left hand side of our RStudio interface, and we can just interpret our we can see that variable 1 and variable 2, variable 1, variable 2 and 5 are highly correlated and well represented in the first plan because the arrow are very close to the circle. The correlation is high. And what is variable 1, 2 and 5? Variable 1, 2 and 5. Variable 1 is the revenue, variable 2 is consumption expenditure. Revenue and consumption expenditure are highly correlated. We have variable 5, which is professional experience, that is highly correlated to revenue and consumption expenditure. So once you have so now variable 5 is level of 1, 2, 3, 4, 5 level of study, and level of study, the most your level of study is higher, your revenue is also higher, and consumption expenditure are involved in the same manner. So we can notice that variable 2 and 3 are correlated but negatively. But what are variable 2 and 3? Variable 2 and 3 are consumption expenditure and number of member household member. So household member are highly correlated but negative. So let us come back in our principal component analysis result. We can present information for individual by using the command result variable by assigning to the result variable value res.pca $sign variable. So result.pca is the result of our PCA. We follow it by the $sign and var, mean that we can assign to that the result of our different variable. Let us select that and click on run, and we have the result of our variable, and we can represent for example the coordinate of our variable on the different component. So I've run this command. We can see that the variable have very higher in absolute value coordinate in the first axis. All variable but not variable 4, but variable 4 have also higher coordinate in the dimension. That confirms the fact that dimension 1 and 2 can be used in order to represent our individual. So we can also have the result for the contribution of individual on as we are on variable. We can have the contribution of variable on the different component result dot $sign contrib to say that we compute the contribution of our variable result on different axes, and we can see that the result are here. So the contribution of individual variable 1, 2, 3 and 5 are very higher in the first dimension, but variable 4 that is very slow in the first dimension is very well contribute highly in the second axis. So we can also confirm the information that the first two axes are sufficient to summarize all information in our database. So if we want to come to build, for example, an indicator using a data set to classify our individual, we can use only the first two components in order to analyze, to compute our indicator. So we can also have the quality of the representation of our variable in axis using the cosine square that is also a result of our variable followed by the dollar symbol and cos to materialize the cosine square of our variable 1, 2, 3 and 5 highly contributed to the first dimension, and the variable for that have a very weak contribution to the first dimension contribute very highly to the second dimension. So we can also confirm here the information that the first two axes can be retained in our principal component analysis, as we have presented the individual result. We can also the variable result. We can also present individual result by first of all computing individual result called res.ind to which we assign the value result for PCA followed by the dollar symbol, and I the reserve word IND to say that here is the result for the individual of our principal component analysis. For the result of our principal component analysis, click on run. You can see that the result of individual for our principal component analysis have been already computed. We have a look at the coordinate of our individual on the axis. So let's click on run. We have the coordinate of all 12 individual on the first two axes. So we can also interpret as we did it for barber. We can also have the contribution of our individual on the axis as we did it for barber, and you can see that there are some individuals that are well represented that contribute highly to the first axis, but those who have a slow contribution to the first axis have generally a good contribution to the second axis. So we can also have the cosine square for individual as we did it for the for barber. We can notice that all our individual are well represented in the dimension, in the first dimension of our principal component analysis. So that's it for this video, and we hope that this video have very well help you understand how to implement the principal component analysis in RStudio. In the next video, we show you how to come deeper in the analysis. And if you are new in this channel, do not hesitate to subscribe to the YouTube channel by clicking on the red button and activating the notification bell in order not to lose the next publication. So anytime soon.